gravity question. This is number 4 on the exercise. So the area bounded by the curve, we have x squared over 9 minus y squared over 4 is equal to 1. The x-axis and the line y is equal to 3 rotates about the y-axis. Find the coordinates of the center of gravity and solid obtained in this way. Right, so now the first thing we need to do is sketch this graph. So what type of graph is it? Right, so we have x squared over a squared minus y squared over b squared is equal to 1. Right, so this is the graph of a central hyperbola. So this is the graph of a central hyperbola. Central hyperbola. So when you see a negative sign in between x squared and y squared on the same side of the equation equal to a number on the other side, you should know that this is a central hyperbola. This we did it in N4. So how does this look? Your central hyperbola, basically you have one branch on the right, another branch on the left, and you have these asymptotes here. So this graph has x-intercepts. Your x-intercepts will be at this point here, so that will be a 0, this will be minus a 0. That's your y-axis, that's your x-axis. We have two asymptotes, we don't have to worry about that at the moment. Right, so this is your central hyperbola. Right, so now let's sketch this graph. So what do we have here? We've got x squared over 9 minus y squared over 4 is equal to 1. So basically the main thing you need to do is find the x-intercept. You don't have to worry about the asymptotes. Right, find the x-intercept. So if I want to find the x-intercept here of any graph, you let y equal to 0. So x-intercepts let y equal to 0. So now I've got x squared over 9 is equal to 1 because 0 squared is 0, 0 divided by anything is 0. So now I have x squared. If I multiply by 9 on both sides, x squared is equal to 9. So therefore x is equal to plus or minus the square root of 9, which is plus or minus 3. Right, so those are the x-intercepts. So let's sketch this graph. So we got our central hyperbola. On this side here, it's cutting the point 3, 0, and on the other side, that will be minus 3, 0. Okay. Now, what else do we need to sketch? The area bounded by the curve, the x-axis and the line y is equal to 3. So y is equal to 3, y is equal to a number is a horizontal line. If x is equal to a number, will be a vertical line. So y is equal to 3. Let's go 1, 2, 3. That is y equal to 3. So we know that this is a 0. And 3. Right. So now this is the graph y is equal to 3. This is the graph x squared over 9 minus y squared over 4 is equal to 1. So we got the area. This is the area that we're talking about. This is the area. The area bounded this area rotates about the y-axis. Okay, so it rotates about the y-axis. Now notice that this part here is symmetrical to the part on the left. So when we are working out volume, we only need to take one part of it and rotate it. When you rotate this, it covers the other part automatically. Or I will take this side, and when I rotate it, it covers the left. Okay. So now, let's draw our representative rectangle. So here is my representative rectangle. I am going to use a rectangle that is perpendicular to the reference axis. So I can use the easier method, which is this method in most of the cases. Right. So now what do I know? Delta y is perpendicular to the reference axis. Which is the reference axis? You go read the question. This is the reference axis. It takes about the y-axis. So our reference axis is y. Right, we know that for sure. So we know that when we're working on volume, it's going to be the disk method. Right, volume is part of the center of gravity. Now, you know when we're rotating about the y-axis, so the coordinates of the center of gravity let's call this x, y. We are rotating about the y-axis, so we know on the y-axis becomes the center, and on the y-axis we know that x is always equal to 0. So we need to find the y value. So we know that y is equal to mx. We take moments about the x-axis divided by volume. Vy, because we are rotating about the y-axis. So y is equal to mx. If you were looking for x is equal to my. Right, so you remember this. Now, this was the important part, volume. Let's work out volume first. So we know that this method, volume is equal to pi r squared h. Area of base times perpendicular height. That is the formula for this method. So what do we know? You go to a diagram and you check you are rotating about the y-axis. So your radius is measured in terms of x. If you are rotating about the x-axis, your radius will be measured in terms of y. Alright, so what do we know? Our radius is measured in terms of x then. Right, the height is equal to delta y. Right, you can always go back and check the questions on volume. And if you're unclear with y, this is the height, and y, that's the radius. So now, compulsory step, delta v y. We are rotating about the y-axis is equal to pi r squared, but we know r is equal to x. So that's going to be x squared times the height. H height is equal to delta y. Right, now we write down the formula for total volume. So now total volume, so we got pi, which is a constant. We are integrating. We're using y values, so that will be c and d. As soon as you put your integration sign in, delta y becomes dy. We are integrating with respect to y, and we have x squared. So, what do we need now? If we are integrating with respect to y, we need the y value at the beginning, the lowest point, the y value at the end. So there's the y value at the beginning, which is a 0. Can you see that? The y value y. So where is x squared? X squared over 9 is equal to x squared over 9 minus y squared over 4 is equal to 1. Let's manipulate that equation. So I know that x squared over 9 minus y squared over 4 is equal to 1. So I know that x squared over 9 is equal to 1 plus y squared over 4. So now x squared over 9, find the LCD. Okay, the best thing to do is find the LCD first, so that becomes 4 plus y squared over 4. Now multiply by 9 on both sides. So x squared is going to equal to 9 over 4 multiplied by 4 plus y squared. Simplify properly in the beginning, then it will make substitution simpler, integration simpler. Okay. So what is x squared? It is 9 over 4, and that is 4 plus y squared dy. So now my constant is 9 over 4 times pi. So that's my constant there. 9 over 4 pi. I need to integrate this part here. So when I integrate 4, I get 4y. Integrate y squared, that will be y to the power 3 over 3. And then we're going to use our calculator and we'll get our answer. I'm going to leave that for a few minutes. Let's set up the mx for a moment and then we use our calculator at the end. Right. So we know this is simple. Okay, there's nothing we need to learn. We know how to use the calculator. Let's deal with mx moments along the x-axis. So we know that delta mx, the formula is volume times the distance of the center of gravity from, if it's x, it's from the x-axis, from the x-axis. Alright, so now there's here from the x-axis, you are measuring a y value. Okay, so now volume. What is volume? There's volume. Okay, so you substitute. Now, you take volume, substitute here, so that's going to be pi x squared delta y. Distance of the center of gravity from the x-axis is y. Okay, so this is how you learn. Do not rely on the formula sheet. The formula sheet is a waste of time for chapter 5. Okay, you learn it properly, write down the formula, substitute, know your volume formula. Right. So now, mx, this is the total. So I got my pi. Now, here I have d and c. So this is x squared y. And now, I'm integrating with respect to y. So that will be dy. Right. So now, it's the same d and c values. So the y value here is 3, the highest point, the lowest point, so that will be 3, 0. What is x squared? X squared, we just worked out now, which is 9 over 4, and that's 4 plus y squared. But this time it's being multiplied by y. dy. So now, what I'm going to do is, I am going to integrate. Now you can remove This is integration. We can remove the brackets, but I'm not going to do it. I'm going to show you, but you need to learn integration by inspection. So this is 4 minus y squared to the power 1, and that's y. So here, if I use integration by inspection, the derivative of y squared is going to be 2y. So if I put a 2 there, I'll multiply by 1 over 2. So this is going to equal to 9 pi over 8. So that's going to be 9 pi over 8. And here this is going to be 4 plus y squared. And then I can integrate 1 plus 1. That's going to be 2 over 2. Substituting 3 and 0. And now I'm ready for the calculator. Alright, so using our calculator, going back to Vy, when we substitute 3 and 0, this is what we get, 189 over 4 pi units to the power 3. When we're working out mx, substituting 3 and 0, we get 1377 over 16 pi. This is units to the power 4. Now to work out our final answer, the formula is mx divided by v1. So this is exactly what I'm doing. So I'm substituting mx divided by vy. So that divided by that, and we get 1,821,428,571, which is equal to 1,281 units, which is correct. So that was the center of gravity when the central hyperbola rotates about the y-axis. Let's deal with another one. Right, our next example. Sketch the area between the curve y is equal to cosec x and the line y is equal to 1, 5 from 0 to pi, or from 0 degrees to 180 degrees. Same thing. Right. Now, then find the points of intersection and then calculate the coordinates of the center of gravity of the solid obtained when the area, the enclosed area, rotates about the x-axis. Right, now, how do we sketch the cosec graph? We need to know the sine graph, and then from the sine graph, in symbol, we work out the cosec graph. Okay, so now, let's take the sine graph. So if I remember, we are dealing with y is equal to cosec of x. This is what we want. Right. Now, cosec is the same as 1 divided by sine. Okay, that's your reciprocal identity. 1 divided by sine is equal to cosec. So, what do we know about the sine graph? Let's take an example of the sine graph. So, let's say if I have maybe g of x is equal to sine x. Right. If I want to sketch the sine graph, first of all, I need to work out the period of the sine graph. You don't just go and sketch it, you need to know the period of the sine graph. So you check the coefficient of x here. If this is a 1, that means the frequency is 1, that means you will have one full graph in 360 degrees. So what you need to do is you always will take 360 degrees and you divide it by whatever you have here, and that gives you 360 degrees or This means that you will have one full cycle in 360 degrees. It's not always the case. If you have 2 here, 360 divided by 2 will be 180. That means you will have one full graph in 180 degrees. If it's 360 divided by 3, 120. You need to work it out. Right, then you need to work out the step values. So to work out your step value, you will take your period and divide it into 4. Okay, minimum 4 points. It's like 4 quarters. So now you take your 360 degrees, divide it by 4. Right, you will always divide by 4 to get your step value. So 360 divided by 4 is 90 degrees. So what does that mean? It means that you are stepping every 90 degrees. You can take out your calculator, you can use the table function on the calculator. What do I mean? If you use a table, let's say we got x, and then I got y is equal to sine x, right? And then let's go for y is equal to cosec x. And let's see what is the difference in these values. Right, so now what values are we dealing with? 0 to pi. Right, so that means we are starting. So this is your start value. This will be your stop value. And you can do this on the calculator. I'm just showing you what you're going to see on the calculator. So I'm starting at 0. Then the next point is 90, because I'm stepping every 90 degrees. So that will be 90 or pi over 2. Remember, 90 degrees is the same as pi over 2 radians, but it's best to work with degrees first. Only when we're dealing with the integration at the end, then we will convert our calculator to radians. So that's 0. 0 plus 90 is 90. 90 plus 90 is 180 degrees. Why are we stopping at 180 degrees? Because that is the restriction. Our domain is from 0 to pi, that means from 0 to 180 degrees. Right, now we need to find out what is the corresponding y value when x is equal to 0. So from your basic sine graph, you should know that when x is equal to 0, sine of 0 is 0. Okay. Then when x is equal to 0, so let's go for 90 degrees now. When x is equal to 90 degrees, sine of 90 is 1. When x is equal to 180 degrees, sine of 180 is back down to 0. You should have this in your head from grade 12. Right. Now, what is cosec of x? Now, cosec means 1 divided by sine x. Right. So that means when x is equal to 0, 1 divided by sine of 0. 1 divided by sine of 0. Sine of 0 is 0. So 1 divided by 0, this is undefined. Even wherever you see sine equal to 0, cosec is undefined. Okay. So now, at 1, sine of 90 is 1, 1 over 1 is still 1. Right, so now we got our 0, 90, 180. So that's my 1 minus 1. Now, the sine graph. Let me show you the sine graph. So this is your sine graph in black. 0, 90, 180. That is your sine graph. Okay, so there's 0, 0. There's 90 and 1 here. 180 and 0. Now, for the cosec graph, wherever you see sine undefined, okay, you draw a vertical asymptote there. So where is sine undefined? At 0 degrees. So that is your asymptote there at 0. Where else is sine undefined at 180 degrees? You draw an asymptote there. Now all you're going to do is take this sine graph and reflect it on that turning point. What do I mean? There's sine. This is sine. Okay. There's your sine coming down. And there's your turning point here. Now what you're going to do is, there's your sine, you take it and you reflect it on this point. That means you're going to take this and it's like you're turning it around and reflecting it. Alright, so what's going to happen is, if you take this and reflect it, it's going to go there and there. So this is sine and this is cosine. Right, so this is sine, this is cosine, so this is exactly what we need to do here. So we're going up there and up here. It must not touch the asymptote because it's undefined. So as we come closer and closer to 180 degrees, the graph goes up and up and it goes up. So as x approaches 180, your cosine graph approaches positive infinity and it goes up. Now, there is our cosine graph. So sketch the area between the curve y is equal to cosine and the line y is equal to 1,5. So if this is 1,5 is somewhere there. So there's your line, y is equal to 1,5. So this is y is equal to 1,5. And this graph here is y is equal to cosine x. Alright, so we have our graphs. Now, we have points of intersection. There's one point here, and there's another point of intersection. We need to find the points of intersection, which is the next question. Now, before we do that, let's draw our representative rectangle. So I told you that if you are rotating, which axis are we rotating about? You're rotating about the x-axis. It's best to use delta x, so we stick to the disk method. Right, so this is what I want to do here. I want to draw a representative rectangle with a breadth of delta x. This area, enclosed area, is going to be rotating about the x-axis. Right, so we're going to be finding the coordinates of the center of rotating around the x-axis. So we know that on the x-axis, y is equal to 0. So we will find that x value. That is what we want to do at the end. But before we do that, let's find the points of intersection. Right, so how do we find points of intersection? We solve simultaneously. So now, let's do those points of intersection. So let's take our two curves, one curve and the other one is a straight line. So now, I got two graphs. Let me call this one y1. Let's call this y2. So we know y1 is touching the top, y2 is touching the bottom of the rectangle. So we got y1 equal to y2. I'm going to equate it, solve simultaneously. Right, so what is y1? It's 1,5 equal to y2, which is cosec of x. Solve for x. Let me give you 2 minutes to solve for x there. It's a trigonometric equation. Right, so trigonometric equation. Let's see what we're going to deal with now. So what do we have here? 1,5 is equal to cosec x. So when we are dealing with a trig equation, equation, always try and get sine, cos, or tan. Okay, sine, cos, or tan. So this is not sine, cos, or tan, it's cosec. So we got 1 comma 5, which is 3 over 2. Cosec is 1 over sine. Okay, cosec is 1 over sine. So what am I going to do? I'm going to invert both sides. So that means if 3 over 2 is equal to 1 over sine, that means 2 over 3 is equal to sine over 1. What I did was invert the left, invert the right. Whatever I do on the left hand side, I must do on the right hand side. So I know that sine x is equal to 2 over 3. Get a calculator. Right, so now working in degrees at the moment. You can work in, well, I think we should go straight for radians. Okay, let's do it both ways. Right, so sine x is equal to 2 over 3, so inverse sine 2 over 3 is equal to, so what am I doing now? Working out the angle. So that will be x is equal to inverse sine 2 over 3, which is equal to 41,8103,149 degrees. So that will be at this point here. Right, this is 90, so this will be the 41,81 degrees. That's it. And this is 3 over 2. So when you're working out this value, you need to understand where does it go. Right, you're putting it straight back here, actual point of intersection. Now there's another point of intersection there. You'll see that. So what do we know from our trig equations? That's C, A, S, T. So what we just worked out here is the first quadrant solution. Sine is positive. This is a positive number. There's no sign, it's positive. So sine is positive in the first quadrant. Where else is sine positive? Second quadrant. Okay, so in the second quadrant, x will equal to 180 minus inverse sine 2 over 3. So we got 180 minus inverse sine 2 over 3, which is 138,189,6851 degrees. Right. So now 138 doesn't make sense to you. Yes, this is 180. So maybe this one, this is 90, it must be in between 90 and 180, which is 138. So you can see there, that is your 138, 19 degrees, and that is 3 over 2. So there's your 2 points of intersection. Then it's sorted. We're putting it on the graph. Now you can write it down here if you want. Now, this is in degrees. Right. Now, from degrees to radians, what do you do? From degrees to radians. The calculator can work out. Right. Right. It has a function there, but how do you convert from degrees to radians? So if it's in degrees, you're dividing by 57.3. Okay, that is just an estimate, 57.3. You're actually doing this now. Let me just write it down. From degrees to radians. Dividing by 57.3 is the same as multiplying by pi over 180. Okay, so if you want to convert from degrees to radians, you multiply by pi over 180. If you want to convert from radians to degrees, you multiply by 180 over pi. Right, so let's take this one. 138,189 times pi over 180 is equal to 2,411,864,997. That's our radians, and here this is going to equal to 0.729727656. Right. So this is degrees, that's radians, degrees, radians. Now, right. So now, what do we want to work out? We are working out, and this graph rotates about the x-axis. So we are working out x, which is going to equal to my over dx. That's what we are working on. Right. Now let's work out the volume first. What is the volume? What do we know? First of all, our representative rectangle, delta x, is perpendicular to the x-axis, and that's what we chose in the beginning. If it's perpendicular to the x-axis, so therefore we are using the disk method to calculate volume. Right. So we know the disk method, volume is equal to pi r squared h, area of base times height. We are dealing with two graphs now. You can see what's touching the top is y1, what's touching the bottom is y2. So it will be volume of the top graph minus volume of the bottom graph. Your radius is measured in terms of y. You can see going around the x-axis, your radius is in terms of y. So let's write down the formula. Delta Vx is equal to pi, top graph minus bottom graph. I call the top y1, so it's going to be y1 squared minus y2 squared delta x. Right, now total volume. We're going to integrate, that's b and a, y1 squared, y2 squared dx. That's a compulsory step, we write that down. Right, so now this is equal to, so what we're going to do is use the radians here. So I'm using 2,4, let's use about 1, 2, 3, 4, 5 decimal here, but I'm just going to round it up here. I'm rounding it up here, but when I actually do the working out, I'm not rounding up here. This is just so I can write it down. 2,412. And the bottom value is 0,729. Well, that will be 73. y1 squared. What is y1 squared? Where is y1? y1? What is y1 equal to? y1 is equal to 1,5, which is 3 over 2. So basically what we are doing, we're taking 3 over 2 and we're squaring it. What is y2? Where is y2? y2 is the actual cosec graph. So there's my y2, which is cosec x squared. Now we need to integrate that. Let's see how we're going to integrate. What do we need to do here? Well, there's nothing much to do here. We can just square this. So this is, let me just erase this part here. Copy down those. I hope you'll copy this down. I'm going to take it down now. This value as it is. This value as it is. Because I need to use this value now. Okay. substituting into the calculator. I am not going to be rounding off anything here. Right, I've got it. Let me erase this here. Right, so let me just copy it down here. So my volume, that's my pi there. That's 2,42, 0,73. 3 over 2 all squared. That's going to be 9 over 4 minus cosec squared x and dx. Alright, so now all I need to do is integrate. So integrate 9 over 4, that's going to be 9 over 4x. Right, integrate cosec squared or minus cosec squared. That is going to give you a positive cot x. Why? Because when you differentiate cot, the derivative of cot is negative cosec squared. So that means when I'm working backwards, when you integrate negative cosec squared, you get positive cot. Right. So now, what are we substituting? Give me the full value. Read out the full value for me then. 2,42. What is it? This one I know is 0.72972766562. This was 2,42. Give me a few more decimal places there. 411. In the exam, you don't have to go and write down all the values, yeah? And it's just that for accuracy, we want to check our final answer. Everybody was getting the same final answer. So we will not round up anyway. Except, this is still volume. Alright, so let me do this. Now, when you are doing this on the calculator, you got 9 over 4x plus cot. You can write it as 1 over 10. Okay. Calculator in radians, yeah, not in degrees now. In radians, so what do I have? 9 over 4 x plus 1 divided by 10. X, what are we substituting? Upper limit is 2.41186 4997. So here I get 4.308662255. That is when I substitute the upper limit into everything here. Put down a minus sign, substitute the lower limit, which is 0.72972766562. I'm getting 2,759921215. Okay, so what do we get? 4.308662255 minus 2.7599121215. Let's double check me there. This is 1,548,741,04. So I'm leaving it in terms of pi. So I'm not going to multiply, work this out. So that times pi, units to the power 3. This is the volume. Okay. Now, what do we need to work out? We worked out the volume. We need now to work out my then. Can you see that? We need to work out my. So what do we know? Delta my is equal to volume times distance of the center of gravity from, if that's y, it will be from the y-axis. So what is volume? Volume was what was it, y1? Yeah, y1 squared minus y2 squared delta x. Distance of the center of gravity from the y-axis will be x. Okay, so now let's do our substitution. Well, let's just write down our total. My is going to be our I, B, A. So that's y1 squared minus y2 squared times x dx. Okay. So now, what do we have? Let's do the substitution. That's I, B, and A. Same B and A. Okay, which is 2,412. And this one is 0,73. Same values, y1 squared. So this is our y1 squared minus y2 squared. You can see that. This was our y1 squared is 9/4. y2 squared is cosec squared. And this is multiplied by x. Okay, now this is equal to pi there, 2,412, 0,73. If I remove these brackets, 9/4 times x will be 9/4x minus cosec squared x times x dx. Alright, how are we going to integrate it? Okay, so here, this is easy. It's these two terms. There's a minus sign separating two terms. So term 1, you integrate it completely different from term 2. Term 1 is straightforward. You're just going to go x squared over 2 and you're done. This is not straightforward. Can you see that? This is multiplication. Minus cosec squared multiplied by x. Multiplication. But this is integration by parts. Alright, let me just pause for a second. Let's see if you can absorb that integration by parts. Alright, so I'm just transferring the information here, from here to here. So integration by parts. We got x and we got cosec squared. Okay. So, or you can write it as minus cosec squared. It's up to you. Let me put it as minus cosec squared. So this will be plus, and now integration by parts. I'm going to go f of x, g of x minus the integral of g of x times f prime x dx. Okay. Now, f of x, we got x and we got cosec, negative cosec squared. Right, from your priority list, x is number 3, cosec squared is the last one, number 5. So f of x is going to be x, and when you integrate minus cosec squared, you're going to get cot, which we just did now. Right, so that's going to be f of x, g of x minus the integral of g of x, which is cot x times f prime x there, which is 1 dx. Alright, so now I got my pi there, and then we got integral of 9 over 4x plus x cot x, and now I can integrate cot. When I integrate cot, it's going to be ln absolute value of sine x, and then I'm done here, plus sin. So let me integrate this part one time too. Remember this integral of 9 over 4x, that's going to be 9 over 4x squared over 2. So everything has been integrated. Substituting my 2,412 and 0,73. And substitute and see what happens. Alright, so I've got 9 over 8 x squared plus x remember the cot you can write as 1 over 10 when you're doing on the calculator. Minus ln sine of x Four, 997. Okay, you can double check me on the calculator. This is what I'm doing now. Substituting. So when I substitute the upper limits, I'm getting 4, 2, 5, 3, 1, 4, 7, 4, 2, 6. Let me substitute the lower limit, 0.73, 0.72, 9, 72, 7, 6562. So I'm getting 1,820, 390689. Get 2,432, 756, 737, and this is units to the power 4. Right. So now let's see. You just double check the calculator right there. That's a big thing. So we know that x is equal to my, which is 2,432,756,737 pi units to the power 4, all divided by your volume 1,54874,104 pi units cubed. You can see pi and pi cancel. You don't even have to type it out. So that's divided by 1.54874,104, and we get 1,571 units. Is that the correct answer? Let's check it. It's 1,571, that is correct. Right, so that is fine. We did not make any mistake. So that is 100% correct, as you can see that? Just be careful when it comes to the integration. Integration by parts, you can see, you must know it. Continue next time.